Everyone, my name is Jenna, and today we're going to talk about trust, blockchain, and cryptocurrencies. But first, I would like to ask you all a question. So, in this room, who trusts me? Wow, that's a lot of people, thank you. But today, for the purpose of this presentation, we're going to assume that I'm not very trustworthy. I might be malicious, I don't know. So, let's start. If you were to buy or provide a service or a good on the internet, you cannot trust the other person, right? You always need to have a middleman between you and the other part. So chances are that you have had to trust this kind of people in your daily transactions over the internet. If you haven't, I believe that you still use credit card or cash, so you still have to trust your bank or government-backed currencies like dollars, euros, and others, and government agencies like the Federal Reserve. If you feel like that now, it's normal, it's okay, and I have a good news. There is a solution. It's called cryptocurrency, which is our subject today. So we cannot talk about cryptocurrency without talking about the Bitcoin, which is widely recognized as the first decentralized cryptocurrency. It was created in 2008 by Satoshi Nakamoto, which is until today, we don't really know who that is. It might be a person, it might be a group of persons. So that person issued a white paper defining the Bitcoin as a purely peer-to-peer version of electronic cash that would allow online payments to be sent directly from one party to another without going through any financial institutions. So basically, this Satoshi person was like, I have this notion of a database. I want it to be public, I want it to be transparent, and I want it to be secured. I want it to be shared across all the network. And on top of that, I want to have a transaction system where people could transfer money, digital assets from one account to the other. So for that purpose, he coupled the groundbreaking blockchain technology with the art of cryptography. So this is the definition of the blockchain. So it's a decentralized ledger of all transactions across a peer-to-peer network. Using this technology, participants can confirm transactions without the need for any central certifying authority. So it enables to completely remove the need for any middleman while transacting over the internet. So the blockchain is nothing more than just a database. It just has a couple of principles. It's public and transparent. Any one of you guys can just go look at it, see all the transactions that have been made since its creation. It's synchronized. It's immutable. This is very important. So it's impossible to alter the data that has been written on the blockchain. As I said, it's distributed and decentralized, so it's not stored anywhere on a server or on a computer. Every participant in the network has a copy of that database, and overall it's secured using the cryptography techniques and highly complex mathematics to ensure the security of the network. So, as I said, you should not trust me about those principles without knowing how it works and why is it that secured. So we're going to see how cryptography is used to secure the network. First, I just want you to just have a visual idea of what it looks like. I will use this little thing. So basically, these blocks tied to each other are the blockchain. If you want to make a new transaction, it has to go through this transaction gate where we would verify that you can actually send that money, that you have this amount of Bitcoin on your account, and then you're the owner, so you have the private key, you have the password for that. We'll see more later in the presentation. So if your transaction is actually verified, it's going to join the next block, which is the next block to be added to the blockchain, right? What happens is that there's a network of all of those people that we call miners. So they're just people like you and I, but they provide computation power from their computer. So they pay a lot of electricity, but basically to run a lot of algorithm to verify that I, Jenna, didn't try to send Bitcoins that are not mine, and that I'm the actual owner of that wallet that I'm trying to use. So if I'm an honest person, they would all validate, they would check on the copy of the database that they have, and they would say, yeah, okay, that person is cool, it's, we can let this transaction join the network. It's going to take a little bit more time. If I'm actually a malicious person and I'm trying to do a transaction which is not like I don't have the Bitcoin to send, I'm trying to maybe steal money or stuff like that, the miners would see that and they would just ignore my transaction. So it would never be added to the blockchain. And if really I wanted to try hard, I would need 51% of the miners to accept my malicious transaction, which is very unlikely. So once my transaction is goes through this and it's added to the next block, it's not done yet. It's not added to the blockchain. So the miners are going to enter a race to mine this block, which just means adding this block to the central, not central, to the general database. So we're going to see how this is done and what makes the verification and validation process so secure. So this is done through cryptography. So the Bitcoin protocol uses two cryptographic hashing functions. One of them that you probably know, SHA-256, and another one that I can't really pronounce the name, but it's just doing the same thing. So in the whole protocol, we use cryptography to generate public key and private key that define your wallet, your kind of account on the blockchain. It's used to verify your digital signature, and it's used to verify that miners also are honest and are doing their job. So I'm going to try to go kind of quickly on this, but I'll send my slides so you'll have the detail. So we use cryptography to generate a public-private key pair. Basically, you have your private key. It's hashed a couple of times to get your public key. And so then when you want to send a transaction or data, you encrypt your message with your public key. And the person that you're sending to will decrypt the message with their private key. So if I'm trying to send Bitcoins that are not mine, or if I'm trying to use someone else's wallet, they would not let me do that because I have to sign every transaction has to be signed with your private key. And then the network will verify that, like through an algorithm, that this signature corresponds with the public key that you're trying to use. So the last thing that is to be verified is the miner's work. So if me, Jenna, I'm a miner and I'm kind of malicious, I want to add falsified blocks to the blockchain, I'm not going to be able to do that either because so once a block of transaction is kind of complete, so like it's between 200 and 300 transactions, we don't know which miner is going to be able to mine it because it's going to be very random. It's kind of like playing the lottery. So we're going to see how that works very quickly. So these are the transactions on the block. Each miner on its computer, so it requires a lot of computation power, is going to hash transactions 2 by 2, and so on and so forth until we have only one hash left. This hash is going to be part of the block header with the previous hash of the last block mined and something that we call a nonce. It's just a random number. To be like the miner elected to mine this block, they're going to have to hash this header a couple of times until they respond to a requirement to have, so for instance here, 4 zeros in the beginning. So it can take some time. It's kind of made to take 10 minutes, so a block is made every 10 minutes. And this process ensures that miners cannot like modify, alter, or hack the network. So cryptocurrency is just the blockchain, so this database and cryptography principles. The good thing about it is that you don't have to trust anyone, and it reduces the costs a lot, and it has, it's increased efficiency for all. What you need to understand is that Bitcoin is just one application of the blockchain, of this technology, and there are like so much more things to be done with it. So this is just an example of all the fields that we could apply this technology to. A lot of people are working on ownership, property title, voting. It's also a huge thing in the financial field. There is a huge consortium of banks that are investing a lot of money on this technology to see how it can improve the financial infrastructure. But the problem is the Bitcoin blockchain cannot be used to do that really, because its programming language is very basic and very restrictive. For instance, you cannot loop, you don't have recursion, you don't have these kind of things. So it's kind of limiting the possibilities. So the last piece of this presentation, there is another blockchain that emerged lately, and its name is Ethereum. It's exactly the same principle as Bitcoin, except that it has what we call a Turing complete programming language. So basically, you can build whatever you want. You can program the money with like very complicated algorithms. You can create smart contracts. It's just the possibilities are really huge. It was created in 2014 by a non-profit organization, and their programming language is really cool. It's called Solidity. If you want to check it out one day, because as JavaScript developers, I think you would understand pretty easily how it works. And this blockchain claims to be the next big thing in terms of bringing this technology more accessible to everyone. And thanks to their programming language, which is very complete, we can just build any app. So anything that you could think about that we have today on the internet, but that requires a trusted third party, is also possible to be built without this trusted third party. So here are a couple of resources, depending on your level of interest and understanding of this presentation. And that's it. Thank you. Any question?